Hey guys, today we are going to talk about the enzymes that your digestive system uses to help you digest food and talk about where and what organs digest what different food groups like carbs or proteins. So today have loaded this note sheet, this video to Edpuzzle so that I know you guys are watching it because I know there's a lot of cheating going on, especially with note sheets. So now I'll know that you at least watch the video. So you go on, you watch the video, you can take notes on the sheet that I linked on Google Classroom, and then you can answer the questions at the end of the video. So you can use your note sheet to answer those, but you will get your grade from Edpuzzle from the questions that I put at the end of the video. All right, so here we go. So these are your different digestive enzymes that you use to digest foods. So we're going to talk about what organ or where or what structure in the body releases them. So this is kind of like where they're produced, right? This is where they are going to get released into. So this is kind of like the where they are used, right? What nutrient, carb, protein, lipid, what nutrient group the enzyme acts on, right? And then what it breaks it down into. So to digest like a carb, if you remember, carbs, the biggest form of a carb is a polysaccharide. And then it goes down to a disaccharide, and then it goes down to a monosaccharide, which is what is usable in our bodies and we can absorb. So it takes more than one enzyme to break down each nutrient group into its most basic unit. So that's what we're going to be going through here today. All right, so first one, salivary amylase, right? Just like it says in its name, right? That is going to be produced in your salivary glands. Gotta excuse my typing, I'm a terrible typer. All right, salivary glands, all right? It is going to be released into, obviously, your mouth because that's where your salivary glands release their saliva. All right, it is going to act on starches. So starches are carbs. All right. The product of the nutrient breakdown. So once you eat a carb, right, you chew it up in your mouth, the salivary amylase in your saliva is going to break that down. It's going to start, so we have starch, right, which is a polysaccharide. Big stuff, big carb. All right. And we are going to break it down into maltose, right, which in this case is a disaccharide. So like a double sugar. So we go from big sugar to a double sugar, but that's not fully digested, right? We've got to turn it into a monosaccharide to be used. All right, so that's salivary amylase, produced in the salivary glands, obviously released into your mouth, in your saliva. All right, it's going to help you digest carbs, large carbs like starches, into maltose, which is a disaccharide. All right, pepsin. All right, that is going to be released from the cells in your stomach lining. All right, so if that's the stomach lining, obviously it gets used in the stomach. Right? There's going to be a different nutrient group. Pepsin starts with a P, just like protein. All right, so you're going to use pepsin to digest proteins in the stomach. All right, so proteins are very large, right? So we are going to break the large protein into, we'll call them smaller polypeptides. Right, into smaller polypeptides. All right, so we're going to take pepsin, all right, produced by cells in the stomach lining, right, released into the stomach. So they're made in the stomach, used in the stomach, right, acts on protein. It's going to break the large proteins into smaller polypeptides, or we could say small proteins. All right, HCl, better known as hydrochloric acid. All right, so you may already know Where do we find hydrochloric acid in our bodies? Right, that is the stomach. Right, so again, right, it's going to be made by cells in the stomach lining. Right, so hydrochloric acid, if you don't know what HCl is, hydrochloric acid, it's going to be made by the cells in the stomach lining. Right, it's going to be released into the stomach. Right, the nutrient group is again protein. All right. And the reason we have the hydrochloric acid, if you remember back at the beginning of the year, we made some proteins out of pipe cleaners and they were kind of like folded up. I think one class I did model it for it, but the other classes probably did that activity to unfold those long protein chains, right? That's the purpose of the hydrochloric acid. So to unfold long protein chains. Right? So pepsin and hydrochloric acid, both in the stomach, work together, right? The hydrochloric acid is going to help to unfold, like break the hydrogen bonds on the long protein chains, right? Kind of unravel them so that the pepsin can get in and break down the proteins into smaller chunks, all right? But protein digestion is not done. We still have something that is too big. We're not all the way down to the building block of a protein yet, which I hope you know what that is, the building block of a protein. We'll get to it in a little while. All right, bile. Okay, organ or structure that makes bile, produces or releases it. All right, so bile is made in the liver. Right, but something else we need to talk about here, all right, the gallbladder. The gallbladder is going to store and concentrate the bile. All right, so your liver makes the bile. The gallbladder is going to store and concentrate the bile. If you have a gallbladder. I got mine removed a few years back. So I don't have a storage. I only have what my liver makes. Now, if you remember from our other videos and lectures, the liver and the gallbladder are considered what's called accessory organs. Food does not go into the liver or the gallbladder, right? So when we make bile, it's not used in the liver or the gallbladder. It's actually going to be used in the small intestine. Especially in that first 10 inches, the duodenum. All right, bile is going to work on our lipids or our fats. All right, so the job of bile is to break down lipids in the small intestine. All right, so the lipids, you got to remember lipids are a little bit of a different property. They're nonpolar, like when you think of oil. All right, it's going to kind of separate them into, we'll call it fat droplets. All right, we are not all the way down into our individual unit yet, our fatty acids, all right, but we are breaking them down from a larger fat into something smaller. All right, next we have the digestive enzyme lipase. Think about the name, lipase, lipid. All right, so guess what? That is a pattern. All right, lipase is going to digest fats. All right, lipase, however, is going to be made in the pancreas. All right, another one of our accessory organs. So because it's made, lipase is made in the pancreas, you are going to release it again into the small intestine. All right, so notice like these, you made salivary amylase in the salivary gland, and then it got released to the mouth. All right, so I guess salivary glands are accessory because these two boxes are different. All right, but here, pepsin, right, was made in the stomach and used in the stomach. All right, so you can tell this is not an accessory. This is not in an accessory organ, but these are accessory organs because this box is different than this box, right? We made it in the pancreas, an accessory organ, but we use it in the small intestine, which is part of the GI tract. All right, lipase is what's actually going to finish off the digestion of fats. All right, so the most basic unit of a fat is a fatty acid and glycerol. I know it's been a while, but that was that great chapter 2 biochemistry test. What were the like building blocks, right? So lipase, made in the pancreas, used in the small intestine, digests fats, lipids, right? Breaks them down into our final smallest product, fatty acids and glycerol. So really, if you think about it, the only place in your body that you digest fats is in the small intestine. All right, next one, pancreatic amylase. Maybe it reminds you of something we talked about, up here, amylase, right? But this one's pancreatic. So guess what? Instead of making it in the salivary glands, we're going to make it in the pancreas. All right, where are we going to use it? Oh, guess what? Another pattern. We're going to use it in the small intestine. So pancreas, pancreas, small intestine for both of these. All right, but this is going to be different. All right, it is amylase. So what nutrient group is it going to act on? Oh, this was amylase also. It worked on carbs. Pancreatic amylase is also going to work on starches, carbs. Right? So again, our pancreatic amylase is going to work on starches or carbs, and just like here, all right, it is going to break down any of those big starches, those big polysaccharides, into smaller sugars, maltose sugars, which are still disaccharides. Anything that we missed in the mouth, we're going to try to get here in the small intestine, but we're not done yet because we haven't got it down to a monosaccharide yet. All right. Trypsin and chymotrypsin, I kind of grouped them together because they are all very similar. All right, so again, we got our patterns. Those are made in the pancreas, right? So they're used in the small intestine because the pancreas always dumps into the small intestine. All right, so trypsin and chymotrypsin, though, are going to work on proteins. Right, so they're going to help us break down our proteins, right? We already got them unfolded and started breaking them into smaller protein chains, so we're going to take those. We'll call them large polypeptides. You can think of them as like medium proteins, right? So we're going to take our larger polypeptides, right? And we're going to break them down into smaller polypeptides. Right, but again, we are not done with them. All right, we have to keep breaking them down until we get them down to the most basic unit of a protein. All right, so here we go. Here's a new one, peptidase. All right, for the first time, we've actually got an enzyme made in the small intestine. All right, so if it's made in the small intestine, it's also going to be used in the small intestine. All right, here's where we're going to start finishing some stuff up. All right, so we made our big proteins into like larger polypeptides and then into smaller polypeptides. All right, so here we're going to take those small polypeptides right, which are proteins. And we are going to make them into the most basic unit of a protein, an amino acid. All right, so technically there, protein digestion is finished. It is in its most basic form. It is in the form of an amino acid. All right, so if we look at our chart, where in our body do we digest proteins? All right, so we digest them in the small intestine, all right, and also in the stomach, right? So you do not do any protein digestion in your mouth. Only places for protein digestion are in the stomach, like we see here, all right, and in the small intestine. All right, and that's protein digestion. It is finished. We got it down to its smallest unit, an amino acid. All right, these may sound familiar, these enzymes, maltase, lactase, sucrase, right? We did some stuff earlier this year with lactose intolerance, right? That means the person does not have the enzyme lactase. Remember, enzymes end in ASE, right? So maltase, lactase, and sucrase are all made in the small intestine, right? In the lining of the small intestine. So again, it's going to be used in the small intestine. Right, so now we're going to take our disaccharides. Right, those are carbs. Now we've got 3 different enzymes here, right? Maltase works on the sugar maltose with an OSE at the end. Lactase, the one you're most familiar with, works on lactose, the milk sugar. And sucrase works on sucrose, which is table sugar. All right, so our disaccharides, maltose, lactose, and sucrose are all going to be broken down by these 3 different enzymes. Each enzyme only works on that specific sugar. All right, and that's going to break it down into our monosaccharides. Right, our glucose. Then that sugar is small enough we can absorb it through the small intestine, because that's the function of the small intestine, to absorb the nutrients into the bloodstream. Now, if you don't have lactase and you don't digest that milk sugar, it's going to pass through the small intestine quickly and give you some discomfort and some diarrhea. All right, so that is our chart, all of our digestive enzymes. I hope you are able to see some patterns, right, in the chart. All right, you can see where digestion takes place. So like proteins we did before, we did the stomach and the small intestine. Carbs, we digest in the mouth and, the small intestine. All right, we finish them up. All right, lipids, we pretty much only digest in the small intestine. All right, so on the bottom of the note sheet here, all right, so there is a little chart down here, all right, but also we use the table above, all right, where do we digest carbs? All right, we digest carbs in the mouth with salivary amylase, and we digest carbs in the small intestine. I can't spell. Right, so we digest them in both places, in the mouth and the small intestine. All right. We also, all right, in what organs do we digest proteins? So we digest proteins in the stomach with our pepsin and our hydrochloric acid. All right, and then we finish them up in the small intestine. Finish them up in the small intestine with our lipase. All right. Oh, sorry. I'm talking about proteins. So finish them up in the small intestine, all right, with our trypsin and chymotrypsin and our peptidase. All right. Here we go. Lipids. All right. So lipids, we're going to start them in the small intestine with our bile that was made in our liver and stored in our gallbladder. And then we're going to finish them up with our lipase, which was made in the pancreas. All right, so lipids only get digested in the small intestine. All right, so notice I do not have the large intestine anywhere on here because most digestion is finished in the small intestine. Really, the only thing the large intestine does is take out the water. All right, this is a graph that we always use, and if we would have had the urinary test in class, it definitely would have been on that test. So using this graph to kind of look at what we were just talking about. All right, so if I look at nutrient line 1, it's the solid line. So it goes here, right, and goes down in the small intestine and then kind of flattens out where we have 0% of undigested food down here at the bottom. All right, notice there I've got my large intestine. All right, so basically what line 1 tells us is that this nutrient, whatever it represents, carbs, lipids, or proteins, gets digested only, right, in the small intestine. So line 1 then would have to be my lipids. I always right click on accident on this computer. Right, so the line 1 would have to be my lipids because the percentage of undigested food goes down only in the small intestine, nowhere else. All right, so line 2, I'm going to let you figure this one out. So if line 2 goes down in the stomach and the small intestine, what nutrient group would that be? Lipid, protein, or carb? All right, and line 3, we see that it goes down, right? So that means it digests some in the mouth, right? But then it stays the same level through the esophagus and the stomach and goes down again in the small intestine. All right, so what nutrient does line 3 represent? Protein, lipid, or carb. All right, this is a nice graph. It shows you where things get digested, and it also kind of hits back at that point that the large intestine really just soaks up water. It doesn't have much to do with nutrients, and the small intestine is really where a lot of the digestion of nutrients is finished. All right, also just to go back for a second, all of this digestion we were talking about today, right, used enzymes. So this is all chemical digestion. We are using enzymes to break down the foods into simpler nutrient groups. So don't forget about that. The other form of digestion, right, was mechanical, which would be like chewing or the stomach churning and pushing it along, right, or peristalsis, pushing things along the digestive tract. All right, so I hope these notes are helpful to you. It is a nice summary for the digestive enzymes and even talking about what each organ is responsible for digestion. So I hope you guys have a good day.